No ale przynajmniej przez barierkę mogę Wam pokazać wahadło Foucault. Myślę, że większość osób je zna i wie, do czego służy i jaka jest zasada działania, ale jeśli nie, to króciutko to wyjaśnię. Otóż do sufitu na bardzo długiej linie przyczepiony jest ciężar. W ten sposób powstaje wahadło, które w przestrzeni po prostu waha się. Teraz wyobraźmy sobie, że na górnym końcu tej liny jest krętlik, który będzie powodował, że ewentualny ruch sufitu będzie neutralizowany. Gdybyśmy taki sufit wprawili teraz w ruch obrotowy, to krętlik na zasadzie bezwładności spowoduje, że wahadło nadal będzie wahało się w tym samym kierunku w przestrzeni. No ale przecież sufit obraca się wraz ze ścianami, podłogą i całą kulą ziemską. Wykonuje przecież jeden obrót dookoła osi w ciągu 24 godzin. Oczywiście ten krętlik neutralizuje to, a więc wahadło waha się cały czas w tym samym kierunku przestrzeni. Oczywiście my to zaobserwujemy jako zmianę położenia wahadła, ponieważ obowiązuje nas względność ruchu. Będziemy to oceniali względem podłogi. Czyli zaobserwujemy to w ten sposób, że to wahadło co chwilkę będzie przewracało kolejne lizaki. Jak widzicie, wahadło Foucault służy do wykazania ruchu obrotowego Ziemi.
Or you put a little motor in the top and give it a little jiggle and put energy in at the top, which is somehow cheating because you're actually pushing the damn thing, and you have to make sure you push it in a way which is not going to cause a torque. So that's the way it's done in a lot of museums. If you see it in a museum, there's not much to see. You go in and 10 minutes later it's hardly moved. You go in 2 hours later and you'll see a big difference. So it's one of those things you should see when you go into the Science Museum and see when you come out, and you'll see the effect.
And so just below the dome there, you have probably one of the more famous Foucault pendulums here in the United States. Now, listen to what the tour guide had to say about how this thing works.
If you're wondering how we keep it going with an electromagnet. Otherwise, due to air friction, it would slow down. We'd have to jump in there every hour or so and give it a push. But our electromagnet keeps it going even after we close at night. It keeps going and swinging back and forth even after we close.
But our electromagnet keeps it going even after we close at night. It keeps going and swinging back and forth even after we close.
You put a little motor in the top and give it a little jiggle and put energy in at the top, which is somehow cheating because you're actually pushing the damn thing, and you have to make sure you push it in a way which is not going to cause a torque. So that's the way it's done in a lot of museums.
Not everyone realizes that they actually have a magnetic drive plugged into electricity that keeps them moving. Now, the only reason I know this is because I worked for a construction company that installed one.
Today I'm going to show you how ridiculous the spinning globe model is by citing real-world applications from construction, in this instance tower cranes that travel on tracks. And we're going to look at the operating procedures regarding cranes that travel. I'm going to give you a couple of examples showing you exactly what goes on, and the results of which of course highlight the absurdity of this spinning globe nonsense. First up, let's just read a couple of paragraphs. If cranes are to travel whilst carrying a load, the jib must, as far as practicable, face the direction of travel. The load must be suspended and as low and as close to the mast as practical. Cranes must not perform slewing and travelling motions simultaneously, and that is the globe killer, okay? They must not perform slewing and travelling motions simultaneously, okay? Bear with me. What that means is not only do they have to travel ridiculously slow across the tracks like we're seeing on our screens now, but they actually have to line the jib up with the railway line in the direction they're travelling. They can't slew, as in can't come off centre from the direction they're travelling because of balance. We're looking up, seeing the crane pointing in the direction of travel, and it's hardly a breakneck speed, as you can see. Now, what I'm going to do now is give you a little bit more of a demo so you've got it, you can grasp fully what I'm saying here. And let me just give you another example. This is your overhead view of your tracks. And here's your tower crane overhead view. Slew ring, back jib, counterweight, front jib. Even though we saw how slow these cranes travel, ridiculously slow, what, 1 maybe 2 miles an hour, they are still not allowed to travel at those ridiculously slow speeds and slew at the same time. They're not allowed to do that for safety reasons. What they need to do is line the jib up with the direction of travel to the radius of whatever it is they're going to be doing, put the brake on, and then they can slew and do the lifts they need to do. And if it's something they're bringing back to the other end of the site, they'll face the direction they're coming and then come back this end doing 1-2 miles an hour. But they are not allowed to travel and slew at the same time, even though they're only travelling at 1 or 2 miles an hour. And that operating procedure, which of course is for health and safety, is what keeps the crane upright so it doesn't go over. But we're expected to believe tower cranes can deal with 600 plus miles an hour spin, going around at 66,000 miles an hour, flying through the vacuum of space at 500,000 miles an hour, wobbling and oscillating. A crane has no problem doing all those different speeds at once. But the moment you introduce a real bit of movement, i.e. the crane on tracks, that can be tested and verified by all, the crane has ridiculous operating restrictions. It can't do its normal procedures. That shows you how ridiculous the globe is. You wouldn't be able to have a machine subjected to all the speeds the globe says are possible. Just wouldn't. And if you could, and that was true, then you'd be able to slew and travel as fast as you liked. Because bearing in mind, you're able to do 600 miles an hour, 500,000 miles an hour, wobble and oscillate, do all these other different speeds. But you can't, because the Earth isn't moving, which is why you need to have serious restrictions in place when a tower crane moves at a couple of miles an hour. It would be impossible for cranes to operate safely on a spinning, wobbling, oscillating ball. Tower cranes on tracks and their operating procedures tell you that. If you can't see this, that's up to you. That's your issues. But the globe is scientifically impossible. It's ridiculous.
Ziemia wraz z nią wielka ściema. Okupiałe społeczeństwo głupie na ten temat. Wielkie korporacje, banki, policja. To zjednoczona wielka koalicja. Kręci się ziemia wraz z nią wielka ściema. Okupiałe społeczeństwo głupie na ten temat. Wielkie korporacje, banki, policja. To zjednoczona wielka koalicja.